All right, so next up is sp hybridization. So we've got two things attached, and we're going to mix one s orbital and one p orbital. And so we're going to have two p orbitals left over. Right, so here's a little diagram of that. Right, we'll end up with two sp orbitals and then two p orbitals left over. So something you see in this is like in a triple bond. So acetylene, this carbon triply bound to another carbon, and then some hydrogens. What these sp orbitals look like is basically just kind of a one-way dumbbell. And so if we have a carbon, it has one of its sp orbitals like this, and then it has another sp orbital going in the back. And so there'll be direct overlap with this sp orbital. And so we'll have electrons in there in a sigma bond. And then on the sides, we've got some hydrogens with their 1s orbital bonding like that in terms of a sigma bond. Drew this a little bit too close. And then where did the double and triple bonds come from? Well, they come from the unhybridized p orbitals. So one is the p orbital right above and below carbon. So there's one pi bond like this. And then there's the other unhybridized orbital in which there's kind of one half of the p orbital is coming out of the board, and then the other half of the p orbital is going into the back of the board. And so there's an electron or a bond there, and they indirectly bond. So a triple bond is made out of one sigma bond and two pi bonds. And so it gets a little cluttered there. So here's a little diagram of that. So on the left, you see the three sigma bonds, right? 1, 2, 3. And then on the right, you see the two additional pi bonds made from the unhybridized orbitals.